Hello everyone, my name is Sonia and I'm a student of Petrozavosdk State University, and I would like to present to you a project I've been working on for several months now. It's dedicated to snow melting and de-icing chemicals used in Petrozavosdk, Karelia, Russia. Petrozavosdk is the city where I was born, that's where I live right now and that's where my family lives, so I care deeply about this place. There's a big problem with how my city deals with all this snow and ice during winter. Usually we cover roads with a mixture of sand and salt, which is effective to some extent, but it makes streets really dirty. And people even deal with the consequences later during the summertime because there's just sand everywhere. It can't be cleaned properly. Besides, there's loads of snow and we collect it in piles. We can see the effect of it during the springtime. Usually these piles just do not melt properly, even when it's warm outside. Like in these pictures, they're covered with dirt from the roads and with sand. So the main issue with sand is that it does not dissolve. So everything that was scattered over the winter remains in the streets of the city. Only a small part of this mixture is removed with the snow. The rest is clogged into the pores of the asphalt and along the roadside. It also rises into the air with the slightest wind. And inhaling such a mixture causes the strongest harm to the human body, so some of it may get into your eyes, for instance. Also, because of the sand, people have to wash their cars more often. It brings other problems like the proper usage of water, and usually people use other chemicals in order to wash their cars, so it's sort of a vicious cycle. Now, what I meant by salt earlier was actually about chemicals. People just use the term salt in everyday life. This salt is the most common reagent that is being used in the main roads typically. Salt causes significant damage to the pedestrians' clothes and shoes and also corrodes tires. It spoils other rubber products and paintwork of cars again. It causes painful ulcers on the paws of animals and it can cause allergic reactions in people. By the way, I have dogs myself and they are the reason why I've chosen this topic exactly. Moreover, salt settles in the soil for many decades and it kills any vegetation, which is really bad for both life below water and life inland. To be more precise, salt together with melted snow is absorbed into the ground or washed into the rivers, which leads to a natural salinization of the soil and water. So it's really concerning. Most chemicals in my city are scattered by eye and nobody talks about the proper dosage of it. There's also a bit of a problem with financial inequity in my country. When better options are found, they first go to the capital, and my region alone just can't cover the expenses. That's why we use sort of damaging but cheap ways to deal with snow and ice. I believe that I can see the future of my country through the lens of these small cities and the problems they have. Since I live in the northern region, snow is quite a problem here. As for the more chemical side of the story, in Russia and Karelia in particular, we mainly use sodium chloride. According to lots of studies, the reduced use of road salt has proved to be good for the roadside vegetation. Also, the salt pollution of the groundwater is a problem, and some scientists have found that road salt that gets into water bodies prevents the natural mixing of water in spring and autumn. Thanks to this process, oxygen and nutrients are evenly distributed in the water, while their lack negatively affects the state of ecosystem and leads to a decrease in animals' populations. Once on the ice, sodium chloride exhibits hygroscopic properties. It absorbs moisture from the air. As we all know, pure water freezes at 0 degrees Celsius. Water with salt will freeze at some lower temperatures. So the main interest when it comes to snow melting and de-icing chemicals, chemistry-wise, is in the interplay of sodium chloride and water at the molecular level. The water usually splits sodium chloride into sodium and chlorine, which are then surrounded by water molecules. With this information, it's important to know what these individuals can do to the environment on their own. I've tried to look for some alternatives to sodium chloride, and the one that grabbed my attention was CMA, calcium magnesium acetate. It is in general similar to sodium chloride in anti-icing. Both can be applied using the same equipment and for similar circumstances, although the effect of CMA decreases significantly at temperatures 5 degrees below 0 Celsius. CMA also melts slower than sodium chloride and it's not effective enough for packed snow and ice. even though CMA causes much less corrosion than sodium chloride. In Karelia, the oxygen content in water is quite low. That's why CMA is not the best for my region. And there comes potassium acetate. It's often used as a pre-wetting agent, and it works even in extremely cold weather, blocking ice formation. Advantages of potassium acetate include reducing chloride's runoff into water and less corrosion to vehicles and public infrastructure. But like all the icing chemicals, it has downsides. It can make road surfaces slick, and like salt and CMA, it lowers oxygen levels in water. But perhaps its greatest flaw is cost. While it's more eco-friendly than other alternatives, in general, potassium acetate costs about 8 times more than salt. Unfortunately, many scientists share the idea that there is no alternative to sand-salt mixtures in the near future, based both on price and on effectiveness. Nowadays, the cheapest and the best performing chemical is calcium chloride. It is effective at low temperatures. It clears quickly, it is fast-acting, less corrosive than rock salt, therefore not as seriously impacting on surface of concrete, lawns and other flora. And maybe one day we will find the better solution to what we have now. I'd also like to express gratitude to the professors and to all students who participated in this international course, and thank you for your attention.